Hi, I want to show you the working of the amplifier, working at full ROS, at full level of VSWR. This is an application where we avoid any kind of alarm protections on the amplifier, because these applications need to work at full VSWR without stop in any way the amplifier, and obviously and mainly without create any kind of damage on the amplifier. So what I will show you the test on a single amplifier of 2.5 kilowatt. This is of course working inside a 15 kilowatt amplifier, but we can do this test on the 15 kilowatt because you will see now in the test it can be dangerous to do this kind of test on a 50 kilowatt amplifier. Of course, we know very well that we will have a high level of VSWR when we have sparks on the cyclotron, but we can make a short circuit directly on the output line of the 50 kilowatt. That is what I will do now. This test, you will see, we will make a short circuit on the output line of the 2.5 kilowatt, and we will test it at different lengths of the cable, just to have different phases of the short circuit. So you know, the short circuit in some case will show to the amplifier short circuit, in other cases will show an open circuit, and mainly we will show the several phases of the short circuit regarding the output of the amplifier. To do that, we have connect the 2.3 kilowatt amplifier to a dummy load. This is the test bench. You see we have a cable where we have created several holes to make the short circuit at different lengths. There is one here, there is one here, there is one here. The bench is done in this way. We have the output cable is coupled to a directional coupler where they take the measurement of forward power that we read here in this power meter. Moreover, we take a sample, we send it to the spectrum analyzer. All this bench is calibrated with the network analyzer, so this measurement of power is very precise, very accurate. So what we will do now is start to showing a short circuit, medium level power, and then we will increase the power up to the maximum to show that in any case the transmitter is always working at maximum power even during the short circuit. Mario, please put it at 1 kilowatt. We will see now, we will make the first test 1 kilowatt. Okay. Okay. Now we will create a short circuit in the first hole. This now show me the short circuit here. Okay. Now, in the meantime, Mario, please make the short circuit. You will see how the power just stopped exactly during the time of the short circuit. And then, again, please, Mario. We have almost no time. Okay. Show the power, power. Mario, now we will make the same short circuit, but in this position. You see, it's a different way to work because it's another phase here. Probably we have higher voltage in this code. Okay, look at the power on the spectrum analyzer. Make a short circuit, please, Mario. Okay. Please look at the output power on the power meter. Make a short circuit, Mario. You see how, Mario, can you please go up on the power, go up 2.5 kilowatts, please, at maximum power. Now we will test it at maximum power at 2.5 kilowatts. We will do the same test at different points of the cable. It's important you note that the power never stops. There is not any kind of protection. Just you see that the power disappear or decrease on the spectrum analyzer because, of course, we are making a short circuit in the output line. So please, Mario, make a short circuit maybe in the first hole. Now it's very big, okay? Please show me, look at the spectrum analyzer, Mario. Make the short circuit. Okay. In the second hole, please. In the third hole, please. Okay. So make, please, in the second hole. Okay. It's now it's almost. The cable is almost taking fire, and this is the dangerous power because we really have 2.5 kilowatt in a short circuit, and it's really dangerous to do this kind of test. But we show you to be sure that when we will have this kind of maybe a spark or some kind of discharge in the cyclotron application, we are sure that nothing will be broken on the amplifier, and then this continues to work without stop in any case, without any alarm, without any case of block of the amplifier. Last things I want to explain is that there is no application, there is never a kind of application where they do that. In any kind of amplifier, what they always do is to stop the amplifier when there is some level of VSWR. Typically at 10% of the level of ROS, the amplifier is stopped to protect it. So we are speaking that at 2.5 kilowatt, the amplifier is stopped, is blocked by VSWR alarm at 250 watt. This is the normal. We are working at 2.5 kilowatt of VSWR level, so it's real a limit application. Well, I hope you enjoy this explanation. Thanks.